So when dealing with inverse variation, we have this product rule that really is nice to use. So if we have 2 points, x1, y1, and x2, y2, and they are solutions to an inverse variation, then we can say that x1 times y1 equals k. We know this, we looked at that. And then x2 times y2 is going to give us k. Well, if these two things give us the same exact k, then we know that x1, y1 is going to equal x2, y2. So we can go straight into x1 times y1 is going to equal x2 times y2 and use that to solve for some unknown. Basically what that's telling us is we have this ratio going on here. And the only thing that changes here is your y2 and y1 are flipped from your x1 and your x2. And that's again because we are talking about the inverse. So when we have the inverse, we flip them upside down. So we're going to use this one right here, the multiplication, a lot to help us find an unknown piece. So let's look at example number 4 here. If y varies inversely as x, and y equals 4 when x equals 7, find x when y equals 14. Write an inverse variation equation and then solve. So we know, using the product rule, that x1 times y1 is going to equal x2 times y2. So I know my x1, first one I'm given is 7, and the y1, the first one I'm given is 4. My x2, I don't know, that's my unknown. My y2 is 14. So I'm going to go ahead and I'm going to solve this. I know 7 times 4 is 28, and that's going to equal 14x. So to solve for x, we divide by 14, divide by 14. I know that x is going to be 2. Now, that's only the solving piece. We didn't actually write the inverse variation equation yet. Well, inverse variation equation tells me x times y equals k. And we just have to plug in that k, remember. So, my inverse equation is x times y. When I did x times y right up here, I got 28. So I know that 7 times 4 is 28. So that's my inverse equation. Look at example number 5 then. If y varies inversely as x and y equals 4 when x equals negative 8, we want to find y when x is negative 4. Write the inverse variation equation and then solve. So again, we're going to use the product rule for this. I'm doing x1 times y1 is going to equal x2 times y2. My x1 is negative 8 times y1 is 4. My x2 is negative 4. My y2 I don't know, so we're going to leave that as y. So I'm going to solve this. I'm going to get negative 32 is going to equal negative 4y. Divide by negative 4. So I'm going to get that y equals 8. And then I also, again, have to write that inverse variation. Well, I know that x times y, to find my k, I just do x times y. Well, I did that. Negative 8 times 4 gave me negative 32. And that's my inverse variation equation. So we're going to use the same idea now in some word problems. Number 6, as the temperature increases, the level of water in a river decreases. That right there is telling me it's an inverse variation. One's increasing while the other one's decreasing. When the temperature was 90 degrees Fahrenheit, the water level was 11 feet. If the temperature was 110 degrees Fahrenheit, what was the level of water in the river? Write an equation to show the above relationship. Well, I know that x is going to be my temperature, and then y is going to be my water level. So we can use that product property that says that we can do x1 times y1 equals x2 times y2. So we're going to go ahead and we're going to do that. Well, x1 is going to be 90, my temperature, times y1 is my first level, my water level, so 11. It's going to equal x2, another temperature, so 110, times my water level, which I don't know, so I'm doing y. So 90 times 11 is going to give me 990, which is going to equal 110y. Divide by 110, divide by 110. So I know that y is going to be 9. So I have 9 feet for a water level. Again, it's also asking me to write the equation. So I need to go ahead and go back and write that inverse variation equation. So I know that x times y is equal to my k. So when I do x times y, well, I know 90 times 11 is going to give me 990 So that would be my K value, and that's my inverse variation equation. Last example here, when two people are balanced on a seesaw, their distance from the center of the seesaw are inversely proportional, so there's that word, to their weights. If a 118-pound person sits 1.8 meters from the center of the seesaw, how far should a 125-pound person sit from the center to balance the seesaw? We want to write an equation to show the above relationship and solve. So in this one, I'm going to make my x be my weight and my y be my distance. So we're going to use that product property again. So we know that x1 and y1 is going to equal x2 times y2. So my first weight I get is 118 times the first distance I get is 1.8. That's going to equal my second weight, which is 125, times the distance, which we don't know, so that's going to be our y value. So when I do 118 times 1.8, I get 212.4 equals 125y. Divide by 125. I get that y is going to be 1.7. So we have about 1.7 meters for my distance. But it's also asking me to write that equation. So I know that x times y has to be my k. To find my k value, I do x times y. 118 times 1.8, and I got 212.4. So your next step is going to be practice for 9-1. If you have any questions, come chat with me before starting it.